A group of sessions will be held to discuss rotary kiln maintenance. This seminar will explain tires. The seminar consists of the following. 1. Tires and tire mounting. 2. Tire clearances. Come on, let's get started the seminar. 1. Tires and tire mounting. Kiln tire, also called riding ring, is one important part of rotary kiln, usually consist of a single annular steel casting, machined to a smooth cylindrical surface. It transmits all gravity of rotary shell, including refractory bricks, internal devices, and raw material to supporting roller. Another definition for rotary kiln tires. The rotary kiln tire, also known as the kiln ring tire or riding ring, is a circular steel ring that is sleeved on the rotary kiln cylinder and fixed by the baffle plate and the splint. As an important rotary kiln part, the use of the kiln tire can effectively transfer the weight of the rotary part of the rotary kiln to the supporting roller part of the rotary kiln. The supporting rollers and other bearing supports carry the full weight of the rotating part. Location of the kiln tires. The properties of the kiln shell steel will determine this. There is longitudinal bending stress between the riding tires that peaks at the midpoint between the riding tires. To simulate the bending stresses along the kiln axis, a model must be developed that takes into account the shell's properties. To prevent fatigue cracking, the riding tires must be positioned so that the maximum bending stress does not exceed the fatigue cracking stress of the kiln shell steel. Formulas are not simple. Tire mounting. 1. Fixed. Usually found on unfired vessels and equipment whose shell temp below 108 degrees C. There are many ways a tire might be fixed on the shell: welded, wedged, keyed. 2. Loose. There are many ways a tire might be loose on the shell: migrating, floating. Watch this video change old tire. Watch this video installing new tires. Kiln tire support system. Tires are mounted over support pads, with machined outer diameter. Precise clearances are maintained, to allow for different rates of expansion, between kiln tire and kiln shell. Tire attachment. Pads. Pads are not welded to the shell, but are trapped in place by guide bars. Stop blocks are welded on one side only, alternating from one side to the other. A pad consists of 1. Stop ring. 2. Guide bars. 3. Stop block. 4. Machine support pad. A loose stop ring is placed between the stop block and the tire. Wear takes place on the replaceable ring, not on the stop blocks. This shows a slightly different version of the floating pad, stop ring design. Bolted support pads. Some FL Smith kilns have bolted support pads. Bolting avoids heavy welds, which lead to shell cracks. The above arrangement uses a wear ring between stop blocks and tire. This arrangement for smaller, light-duty kilns uses stop blocks directly against the tire, without the use of wear rings. Tire attachment. On kilns without wear rings, when the blocks eventually wear down, they have to be cut off, and new ones re-welded. Clearance between retaining ring and tire for rotary kiln equals about 4 mm. Ring retainer. Limit the movement of the tire as it travels back and forth on the turning rollers. As the tire rubs against the stop blocks, wear occurs. A tire that is thrusting against the stop blocks will wear and cause damage. Without attention, the stop blocks will break or require replacing. Rotary kiln tire creep, migration. He knows the relative movement between the tire and the kiln shell. Limit the movement of the tire as it travels back and forth on the turning rollers. As the tire rubs against the stop blocks, wear occurs. A tire that is thrusting against the stop blocks will wear and cause damage. Without attention, the stop blocks will break or require replacing. Measuring migration. By making a mark with a soapstone, from the side face of the tire to the surface of the pad. It's possible to witness the mark slowly separate from the two surfaces during each rotation. This separation is a direct measurement of the fit between the shell pad, outside diameter, and the tire inside diameter. Tire clearance. When a kiln is heated, the shell expands more than the tire. Consequently, tire clearance is necessary to prevent shell deformation. The principal function of the tire is to provide the structural support necessary to maintain a circular shell axis. When the tire clearance is too high, the tire is too loose to provide this support, and high ovality results. Shimming or replacement of the support pads is necessary to lower the high ovality. The tire clearance, S. Relative movement, migration, U, between the tire and the shell. U, equal, pi multiplied by, outside diameter, minus inside diameter. OD, outside diameter of kiln shell, above chairs, pads. ID, tire inside diameter. U, equal, pi multiplied by, S. S, theoretical clearance between the two perfect cylinders. Theoretically, U, equal, pi multiplied by, S. But practically U, equal, 2 multiplied by, S only. The tire clearance. It is necessary to have clearance, between the tire support pads, and tire inside diameter, to accommodate heat expansion of the shell. Cold clearance is typically, 6 to 12 mm for a new kiln, depending on the location of the tire. Tire clearance. In this case, the shell will heat up faster, and expand more than the tire, and clearance will diminish. Normal hot running clearance should be from 0 to 3 mm. Tire clearance correction. The only option if the lining near the tire is unsatisfactory and the tire clearance is too large, is to correct the excessive clearance. By inserting shims, or replacing the old pads, with new pads of suitable thickness, this can be accomplished. To evaluate the shim thickness, the clearance should be recorded, and plotted for a week. Based on lowest recorded clearance, the shim thickness is calculated as below. P equal A 1/2, SM, minus SS. Where P equal required shim thickness. SM equal minimum clearance recorded, during the period. SS equal safety clearance, this can be 3 to 5 mm. In case of bolted pads, the shims can be inserted by loosening the bolts, and inserting shims between shell and pads. In case of welded pads, the shims can be tack welded over the pads, as a short-term measure, and during long shutdown of kiln, the old pads can be replaced by new pads of correct thickness. In this photo we watch two cases. 1. The distance between tire and shell, when cold condition. The gap is too large. 2. The distance between tire and shell, when hot condition. The gap reduced to normal. Important. The clearance is important in order to allow the kiln shell to expand when heating up, without getting damaged by the tire. In this photo we watch, gap is too large when hot condition. But once the filler bars are worn down, the clearance between kiln shell and tire becomes too large, which causes increased ovality and mechanical stress. This photo after reshimming. The gap reduced to normal. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.